Oh my God. Okay, hello. Hello. Is it live? Okay, as you see, I've been having some problems with OBS. So like the first 2 hours of this are lost. Well, that's crazy. I'm trying to find my stream. Hold on. Okay, yeah. It's working now. But basically as an update, the main change is that I can now do parallel training and this cosine thing. But there's no like structural like changes. But it's like now the training is done in parallel. So all the learning rates for one model architecture get executed at once, so it can do a lot faster. And then I'm just trying to run the chinchilla, like get some level of chinchilla loss. So take that learning rate and train like five of the same model. Uh, because like there's probably gonna be some ensembling effects of some sort going on. So just like getting that will be pretty good. Speaking of which, I probably need to change this API. How does it? Jax random.key 41, right? So do this. Basically taking keys. I don't know why I was creating it. I wasn't even using it. Uh, for key and keys. Should be fine. I honestly don't know about these grid sweeps. Like, basically, we can take the best LR from every model. I also do 79 I did, yeah. Okay, so for LR and best LRs, now what I'm gonna do is for I in range of n models, final losses is this. Okay, so I'm gonna basically just do this, but instead of varying the learning rate times how many? Let's see. We'll do 10. Yeah, 10 of the same model. Jax.random.key for I and J and test, right? And I'm gonna be doing best LRs of I times n test. So now we get, yeah, and a sweep, basically a big sweep. Best LRs. And that should now work. Losses. What did I just do? Basically just get rid of. Um, oh, no need for this. Best losses scale. Bam. Yes. Okay, so let's just update import trainer again. That's the LRs of I times. Oh, how do you, what? Hold on. Also, yeah. So yeah, now we'll get like 10 data points. Like in theory, I should do like some average or like standard deviation, but I just want to see what the variance is for different keys at the same learning rate. Oh wait, which model am I using? Oh, it's about, okay, that's accurate, yeah. Are we compiling again? This number instead of what was it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's actually 10 as well. That's not even planned. Oh no, it's just because of black. Okay. Well, we can see, yeah, there's quite a bit of variation in the final losses, despite using the same learning rates. But for like this one, it's pretty consistently like low, right? That's crazy. This one is weird. Like, why are they all so bad except for some that are so good? It's not normal. Even the final accuracies have so much variance between them. Okay, and then this one, yeah. See, like they're just lower, right? In general. No, this one gets to a surprisingly low number. Final accuracies. Wow. 98%. Yeah, so the other thing is like I guess because it's maybe like with the low parameter size model, initialization matters even more. Um, even though like I don't know, like these are higher parameters and they have like just these absurd looking things. Could be because of learning rate too, but I added the cosine decay. I don't know. Hell no. So this is a lot better than most. Although accuracy is not as good, actually. It's like this one. It hit 0.06 on one of its rounds. It just happens, I guess. How many models? Is it also 10? 11. So we should be nearly done. Okay, and then this model just does not have the capacity. You know, you're looking here. It doesn't really have the capacity to learn much. So there's our scaling law. Bam. It does not look like a smooth parabola at all. There's like a sweet spot over here. What is it? Anyway, we'll do that in a little bit, but that is diabolical. Alright. So what does it imply? Like what do I learn from this stuff? I guess I can just use the averages, yeah. This one's like just on average way, way cleaner. Is using a different learning rate? Model 6. That's like using the same learning rate as all those. Okay, well, good for you. 2, 3, 4, 0, 1, 2, 3, 4, 5, 6. Oh, see, like big enough to like have an impact, but has enough tokens to where like, you know, it can actually do something about it. Interesting. So what if I change the floss budget? Let's go down by let's go down by a good amount. So yeah, should also be faster, which is nice. The other question is like, how will this be impactful on the scale of like what if I go larger in flops? Should I even have even like a smaller model just to see? Yeah, why not, right? Actually, this probably is too small. It's probably too small. Yeah, like this is as small as you want. Okay, I don't know, like none of these are learning anything, right? They just they literally see like no data. How much data do they get to see? They get to see 1,500 additions. Then only these ones can actually see enough of the additions. I think this is probably a key metric to track is like how many additions do you need to see as a transformer to generalize? Constant training. They're just yeah, completely clueless as AI models. There we go. There we go. Yeah. Thing is, if Model 6 is the, oh no, it shouldn't be. Although it's better than this. Wow, this one it's not great. What learning rate do they use? Did they converge on different learning rates? No, I know. I've actually got anything. Definitely this. Oh wow. See, like this one, someone can get to 99% because on one of its at least, right? Because I actually saw something. Da, 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 da. What is this initialization gamble? Current average losses. Yeah, that's what I want to see. Okay, so the second to last model was the best, and then the last model couldn't handle it. Smooth, kind of. Between the oh wow, that's a sizable difference. So the token budgets were so this guy sees like double as much as this one. What have a capital? So we'll just try it. Um. Anyway, so this is like a flops budget, which is low, right? On the low end. What if we go back up? So let's climb back up to the slightly higher end. And as we see, insane amounts of tokens that these guys will be able to see. And this will take a longer time, but yeah, I mean, we should see some models actually saturate this one completely. Like this one is almost saturated already. Chance that even the bigger models, like models saturate this one better. Because that will basically like prove that there's some level of chinchilla level scaling that can be found. And that's like really awesome. Right? But still remains to be seen. This is this model did quite good. I wonder if it was just like a really good initialization. No, it might not be. Might be that model 4 is like yeah, it's like gonna scope it out like that. There's a tall order to fit this function. All of the other ones should do pretty decent. Considering they already did pretty decent, seeing like 1/10 of the data that they saw. Okay. The other thing is like maybe worth to Try LR3X. Suits. I don't know if it'll make a difference. And tiny scale model initializations. Hmm. Why is this so bad? Oh, bad and then good. Whoa. Feel like yeah, it kind of does just feel like a random number generator again. And then because the worst models have more chance of getting like yeah. Mm. Yeah, it does seem like it's just like a it's not gonna be parabola like this shape here. Ew. This is loss. This is number tokens. Like we do it for like that's I mean these are interesting functions with that. How can I? Yeah, I'm just worried that LR selection might not be the best. Is there any trend that I'm observing? It's almost always these two, right? So can't I like clamp the scale? Like we should not be doing this in -4 rounds. Or even like the one in -3. Let's model to 3 in -3, which is leave that there. Basically, I want to do HLR and I want to do two different kinds of keys, or maybe even like three different kinds of keys per LR. Okay, see, this model is too small to learn it, no matter what. It's just too tiny. Yeah, 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 yeah. Um, do this one done. Keying keys. A good idea. No, it's not quite a good. It's almost a good idea. Okay, I honestly don't mind just doing this. So I use 5 LRs, but I use 3 different seeds. But I actually want to do just just do this. This is the least programming language. Nicely. This model is just like acing everything. That's good. But this model also kind of got one insane ace. It could have just been a lucky valve after it's 1,000. So we're doing a lot of averaging. That hopefully means I don't have to do any like accounting of like the amount of degrees of variance or whatever. I don't want to put error bars on my numbers, basically. I'm not live? Oh, the icon is just weird. Yes. Yeah, I can see it. Okay. That's scary that the OBS icon is not showing. Like, imagine if I didn't know I was live. As you get to the really small models, part of the issue just becomes that they are not stable, I guess. And they're using really high learning rates too. But I mean, I have cosine at the end. Cosine is magic. So I'll do one more, and then I can create the pipeline and actually run the things I've taught them um, by tomorrow. So today I'm gonna have some fun and hang out with my friends. Yeah, ensemble. I can also take the median model. Maybe better in this case. Like if you don't want to, you don't care about time complexity because you're doing a list of 10, you can get a median that way. Yeah, you have it. Look, it's okay, even if my okay, lower, 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 lowest, higher, higher, lower, higher, 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 highest. What if I just change untest to 20 next time? No one will buy that. I talked to who is no one. I don't know. Okay. It's pretty much confirming that then. Now, my parameter goes from very high to very low. The other thing I want to test is doubling the number of layers. That's going to double the number of models to train to. Um, what do you think? So based on this result, oh yeah, I do want to see like what happens if I double the number of layers. Okay, this is my last run of the day. It's gonna be some diabolical stuff. Two, two. Okay, these are the budgets. Yeah, this is like half this one. Yeah, but except the vocab is such a yeah. Interesting. I can foresee no issues. All right, while that's happening, I'm just gonna confirm my and stuff. I'm gonna repeat that. PM. Oh, that's some time. 22 models. That's a lot of AI models. Having too much fun with it. I think it's because I'm like, I don't know. I don't know why I'm having fun. And I don't need to tell you. Okay, hold on. One, two, three. Yeah. One, two, three. Interesting. One, two, three. Interesting. Yeah. So very similar songs. These are extremely close. Like it makes me wonder if the keys were probably right. I think they must have. Okay. Why are they getting longer? Does each model just have more decimals? Or is it because 0 is wider than 1? So the models that are better have no, like it has predictably more zeros. No, why is this one longer? It just has more decimals for some reason. No, it's because these all match up. Yeah, I mean, it just has more zeros. Okay, I accept it. Wow, maybe I should be using average instead. It's too bad. So this one actually uses a lower learn, slightly lower than this one. Interesting. Also, what was the end result? It's just superior. This one. Interesting. So it's at the burrito. Burrito. Sounds like burrito. Not the first person to make that joke out. We are at the burrito frontier of innovation. It's interesting. One of the low learning, but it's much better here. Even better there. Yeah, mixture of experts. Mixture of experts. We are we are creating a mixture of experts today. That is what we are doing. Ah. So the router should be Yeah, how do you route it? No, I can't hum this. It's from a song. But these are also really good. That's concerning. Like, why is there like this middle section where they're not as good? It's still like twice the amount of models to train. I don't know, it's like half the amount of steps per mod. The switch transformer was a switch transformer layer that receives two inputs and has four exports. Oh, interesting. Router has an exponentiation function. I don't care about the precision related stuff. The thing is, like, I'm only a decoder. Given a fixed compute budget for pre-training, a sparse model will be more optimal. Yeah, like that's why we want to use the sparse model. Really care about parallelism for this one. Like we already did some of that in the book. Thing I care about is building the MOE in such a way that it churns, you know? I don't want to just not have it churn. Mixture of experts routing. Naming GPU. Mini transformer mixture. Hella swag. What? Okay. Common sense is hella swag. I agree. Okay, with 2 layers, they just suck on limited compute budget. Well, they're all so bad. Oh my god. How many are these guys seeing? Yeah, they're seeing less tokens, so I guess they should be complaining. Oh god. Reconnect, please, please. Industry adoption. I mean, I understand that we can use expert parallelism, but tell me what the matrix mode is. Okay. Yes, a deep dive into MOE routing with DeepSeek. Expert layer 1, expert layer 2, expert layer all the way to expert layer M. And it aggregates them. Goes to output. So the gating network is what we care about. PI, softmax, W router, X. I mean, they all just say they do that. I don't know if I believe it though. Beneficial intelligence. Each selected expert. Yeah, okay. I guess I just want to see the math behind it. Mhm. Wow, this is just horrible. Model 19, you are not good. Basically, none of the two-layer models are good. Okay, got it. So I'm just gonna cut them off in that case. Leave model 11. Still a one-layer model. How can I verify this? Could be model 10, that's the last one. So 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6, 7, 11. Okay, so cut off at 12 then. Hmm. Yeah, there's absolutely zero reasons like try to train this. And is it maybe because they need a higher batch size or something? Why are they so bad? Like what they weren't this bad earlier. Like it still learns some, right? It's like, oh, they need lower learning rates. So maybe I'm being unfair to them. They probably need lower learning rates. Yeah. It's not like it's a monotonic. They probably do need lower learning rates. Okay. I'll find no, but that doesn't make sense. 1, 2, 3, 4, 5, 6. Yeah, no. I don't know. They still learn some. Just not well. Okay. Reshape that. Self-dot router, which is just a linear layer. Mm. Wait, but that fixes your batch size. Why is it a linear layer? Oh, no, 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 that's the shape of router logics. Okay, the shape of W router, it's gonna be a shape of number of, it's gonna be hidden dimensions times number of experts, right? I'm trying right now, it's the memory to term init func self dot, okay, so it's gonna be self dot d self dot e dimension number of experts. Yeah, that's what they're doing. Go first. Use Celu, but I'm using Jelly. Shouldn't matter. I'm just saying n belongs to 12 for the love of the game or something. W router expert probabilities. Copy the condition. Router logic equals jmp.item. This is what e. I'm not gonna use ragged dot. That's a lot. Number of experts times what? No. What am I saying? Ed, comma, etd to etw router. Okay, yeah. Are they doing a ragged dot though? No, they're doing some loop, huh? No. Output tensor. That's definitely not what I want to do. Jax.lax.ragged dot. Uh-huh. Oh, did I make sure to set the data type, by the way? Let's do that before I forget. Components, clear block. No, wrong component. Okay. They're yelling in the room next to me. Okay. That has type B Phillips 16. That looks good. So yeah, I mean there's a very smooth looking like transition, you know what I mean? Looks like the solution is you have to constrain it to where like it doesn't learn. It doesn't like have enough to learn. And then you can get chinchilla loss. Um happy. W router logics, right? And what I need to do is it's like related to like that collab I did earlier. Um like this one, kind of, right? And we'll emote. Yeah, so it sends them. This isn't ragged. It's just kind of a little bit padded. This is like how is this possible in the same learning rate, the same models to just have this in general. But like one of the models got a 97. And some of the models are just stuck at like a 33%. You really gotta wonder. This one is better. Looks like that model in particular just stuck. Did it choose a different learning rate? Let's see. If model 7 chose a different learning rate than model 8, that could explain that. Yeah, it did, huh? So it's very inconsistent. The higher learning rates are very inconsistent. Maybe I should just ban those. Or just use mean like a normal person. I'm gonna ban them. I'll ban them. It's too unstable. I actually need a better way of. Oops. This is so good. What? Yeah, expert 8. Number 8. Use the actual learning rate it should be. I can fix the learning rate, I realize. 0, 1, 2, 3, 4, 5, 6. Okay. How's 5 compared to 6? And how's 5 compared to both 6 and 7? Yeah, it's worse than both. Is it? Mm. Yeah, it is. I think it's worse. I can just fix the learning rate. It's model 90s. It's using the same one. Yeah, I mean, when the models get super small, see, no, it's using the weird, but it's still super inconsistent. I guess that's just how things go. Two more. Um, I need to do more research for this one. Router logics. JNP answer. Yeah, I good thought. Okay, and shift array. Right, because it's all grouped. But if your output is an n by n shaped array, huh? Um, this thing is almost done. I just want to see any like of these shapes, you know? And using min is bad. Best LRs. Um, also, are we done? No. This is very simple. Reps equals 3, right? So instead of doing this, that's nonsense. Um, that means that keys will equal to um model. Right. Yeah, so LRs is equal to LRs times reps. and key is equal to um it's like so weird, right? This elements k times Python. Is that true? Wait, what? LR for in graphs or is that no? Just here. Down, 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 up, 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 down, down. So it's slightly spike, right? Let's see, how's this? Up, 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 down, 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 up, down, 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 up, down, up, up, down. It's kind of good, except for like one that's like a major outlier. Just fine, but LR is equals, right? P is equals to Q of 42 plus I for I in range of X times length of LRs. And LRs. Mhm. And now you can just pass in keys for keys for LRs, right? Um, but now instead of doing this, right, what you do is you take um on average, yeah, for I in range of length of LRs repeated for J in range, for K in range, length of for K in range of reps. Plus equals um J plus K of losses, right? Losses dot. Okay. Min of yeah, something like this probably works. And maybe you can do like 4 reps and do a little bit more dense of a grid. Just pretend they never existed. 3, -3, 5, -3. Do 4 reps. Wow, so it's a lot. Let's change the models. So let's get rid of this 12. So it says wonderful. For J in range of length of LRs repeated, unrepeated. We'll never know. We're not using our TPU yet. That's not good. Definitely did not run. Oh, 0. It was so fast too, you know? It's actually cached it. Yeah. What? Hmm. Okay. Is it too late to say this is officially hella bugged? What's going on here? Best losses. Best LR style pen. LR is unrepeated. That's proper. Index of the mean of the average losses. Yeah. So the only issue is that my average losses is constructed out. Well, let's see what average losses looks like. As it now prints it out. Oh, it has to compile again. No. Losses. Average losses. Oh, that's not. But surprisingly, why are you lowering? Because how many? There's 1, 2, 3, 4, 5, 6, 7, 8. Here's doing 1, 2, 3, 4, 5, 6, 7. Yeah. Is it sorted or something? It must be like sorted. No, I'm just sorting elsewhere for other stuff. I'm 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 shocked. That's doing something. Finals of losses. And dividing by reps is like a start, but that doesn't address the issue here. Just print out finals of losses. Okay. So no, it gets higher at the end. Yeah. What the? It's like confusing me so much. Yeah, those are accuracies. But then for some reason, this is like in some sorted order, you know? Like it's already wrong here. So, right. that's definitely wrong. So what's the deal? Average losses dot append LR average. Ah, I'm like done. I'm like done. I just need to figure this out. For J and range of length of LR is unrepeated. It definitely runs the correct amount of times that we want it to. This is gonna run 4 times. So it may be better to directly calculate the average. Okay, just using a quick average calculator. So this is the average. Yeah, that looks good. Then this one, yeah. So how can we go wrong? Oh, J plus K. Now it's fixed. I know it's fixed. I'm so embarrassed. Okay, I'm done for today then. I'll end the stream. Got like a kind of working pipeline for a chinchilla that I can use later. And then I need to implement the mixture of experts. And then after that, I need to do the palace card. Okay, these 4 things.